We work on micro robots. These are particles that are engineered to self-propel or move or change shape in response to a stimulus like a magnetic field, an acoustic field, or an electric field. To give you perspective, the human hair is about 50 to 100 microns in diameter, and these particles are 10 times smaller to 100 times smaller than that. A lot of the microrobots that we are developing, we're using for local drug delivery. Our bodies are replete with biological barriers. These are the same barriers that keep us safe from pathogens and other diseases, but that makes it hard for drugs to penetrate. Anytime you administer a drug systemically in the body, it's going to go to many different tissues throughout the body. But if you can locally deliver a robot containing a drug, that basically helps to constrain that drug to that environment of interest, and it spares a lot of the rest of the body where you could have toxic effects. The idea with microrobots is that we can essentially direct where these drugs go more specifically. Here we have these particles, they have a shape in some cases like this, like a corkscrew, and they're magnetic. And so what you can do is you can impose a rotating magnetic field, and that results in this rotation translational coupling, and the particle starts to basically twist, and it can burrow its way into a surface or through a fluid like mucus fairly efficiently. We've been able to start to manufacture these robots from materials that are biodegradable. And so now we can start to make these little machines that not only can self-propel and they can navigate complex environments, they can explore large surface areas, for example, like the lungs or the bladder, but then they can start to break down into components that are safe and they're easily metabolized by the body. And these are particles that have the capacity to respond to stimulation from ultrasound or from magnetic fields. And the idea is that we can impart local forces and torques on these particles to direct their motion. It's hard to say how long it will take for that to be realized. There's a lot of work left to be done. The Packard Fellowship has been a game changer for my lab because it's allowed us to take on these really high-risk areas of research that normally we wouldn't want to pursue necessarily so early. And it's also been enabling from just a flexibility perspective. We've been able to pivot. We find something really interesting in the lab and we've been able to switch gears. And so we've been able to think about really big problems and really difficult problems at a much earlier point in time in our careers.